Okay, let's see what we've got. Well, number 1 has been done for you. Number 2, the simple way to write that is to say 7 less than or equal to p less than 12. The next one we would write as 5 less than x less than 7. The next one, well, if x is, let me see, if x is less than 4, then it's automatically less than 6. So the second conjunct here is superfluous. We could just write that as x less than 4. What about the next one? Well, y squared less than 9 means, let me see, negative 3 is less than y is less than 3. That's what that's what the second conjunct means. Okay. But if y satisfies this condition, then certainly y is less than 4. So the first conjunct is superfluous, and the only one that counts is the second one. So we could simply write that as y squared less than 9. Okay, that was just our thinking on the way. What about this one? Well, x is greater than or equal to 0, and it's less than or equal to 0. There's only one possibility, and that's x equals 0. Well, for number 3, in order to show that the conjunction is true, what you would do is show that all of phi 1, phi 2, etc., up to phi n are true. And for number 4, to show that a conjunction is false, is you show that 1 of phi 1, phi 2, phi n is false. So you have to find one of these, at least one of these, which is false, and then it follows that the conjunct is false. Okay, well that's that one. Okay, well with part A, if pi is bigger than 10, then it's automatically bigger than 3. So in terms of the disjunct, pi bigger than 3 dominates. That says more. And if we draw a picture, we've got 0, we've got 3, we've got 10. And the first one says that x is to the right of this point, and the second disjunct says that x is to the right of that point, and the disjunction will be true if at least one of them is true, and at least one of them will be true if we start at 3. First of all, only the first disjunct is correct, and then when we get beyond this point, both disjuncts are correct. So that's the first one that works. This says that either x is less than 0 or x is greater than 0, so the simplest way to write that is to say that x is not equal to 0. It's either less than 0, it's negative, or it's bigger than 0, it's positive. This says that x equals 0 or x is greater than 0. The standard abbreviation for that is x greater than or equal to 0. And once you've got x greater than or equal to 0, that's going to dominate over the first disjunct in terms of a disjunction. So you're going to have x greater than or equal to 0. That makes a more general claim of the two. And for this one, let me make a note that x squared greater than 9, this part, means that either x is greater than 3 or x is less than negative 3. Well, one of these two disjuncts is the one that's here. So this one is superfluous. So that's the one that counts. So x squared greater than 9 is a simple way of saying it. And again, as with the previous case, as with numbers 1 and 2, as I was going through them, I actually articulated what these things are. And these were really just to sort of prompt you to thinking about how you would express them in English. Okay, well that's that one. Well, in number 7, to show that a disjunction is true, you have to show that one of them is true, at least one of them. And for number 8, to show that it's false, you have to show that all of phi 1, phi 2, etc. to phi n are false. Okay, well, that's number 7 and 8 taken care of. Right, turning to number 9 now, to say that it's not the case that pi is greater than 3.2 is to say that pi is less than or equal to 3.2. When you negate a strict greater than, you get less than or equal to. To say that it's not the case that x is negative is to say that x is greater than or equal to 0. To say that it's not the, well, these are real numbers from the context of the expression. We can assume that these are talking about real numbers. And for a real number, every real number has a square which is strictly positive with one exception, and that exception is 0. So the only real number for which it's not the case that x squared is strictly positive is x equals 0. The standard abbreviation for not x equals 1 is x not equal to 1. And when you negate a negation, it takes you back to the original statement. And again, as I went through them, I essentially answered number 10. Well, this question is much more difficult than all of the other ones. And the reason is that you take statements in natural language, and they have all sorts of ambiguities, they have nuances, they depend upon context for their interpretation, they depend upon knowledge of the world. And when you try to distill out precise mathematical meanings, there's so much lost that in many cases it's not exactly clear which the right answer is. I don't think that's the case with the first one. I think that's fairly straightforward. That's just D and Y. I think the second one is fairly straightforward too. Okay, the dollar is weak, and as a result, the trade agreement fails. Okay, there's a definite implication in this one, I think. This one, I think this is much less clear. I would be inclined to say that the dollar is weak, and the yen is strong, and there's a trade agreement. In other words, I'm not interpreting this as saying that the trade agreement implied that. I'm simply saying that there was a trade agreement, and then after the trade agreement, it turned out that the dollar was weak and the yen is strong. Now you may say, no, this should be interpreted as that this implies that, in which case the alternative would be there's a trade agreement, and as a result, the dollar is weak and the yen is strong. So that would be an alternative. Incidentally, later on, when we look at the way conjunction and disjunction, negation and implication behave, we'll be in a position to examine and analyse the connection between a statement like this and a statement like that. You know, are they equivalent? Are they different? In what way are they different? Okay, let's move ahead. Strong dollar means a weak yen. I think there's a definite implication there. Strong dollar means the yen is weak. Despite, I think that to me that's just a nuance on conjunction actually. I would be inclined to say that's that. The yen is weak, there's a trade agreement, and the dollar is strong. Just a straightforward conjunction of the three. And that despite adds an extra sort of emphasis that it's counter to what one might normally expect. Okay, this one I think is fairly straightforward. If one of them is the case, the other one cannot be the case. I've said that if the dollar's strong, the yen has to be weak. The alternative that you might want to say is if the yen is strong, then the dollar is weak. Again, when we look at the calculus that tells us how negation, implication and so forth interact and affect each other, we'll be able to investigate whether or not that and that are actually equivalent. So bear this example in mind when we come to the next couple of lectures. G, if new trade agreement is signed, dollar and yen can't both remain strong. I think that one's fairly straightforward. If the trade agreement's signed, then you can't have them both strong. Someone's going to win and someone's going to lose. This one, I think, to me, I can only really see one interpretation of this. It's conjunction. T and not D and not Y. You can have the trade agreement, and you can have the dollar falling and the yen falling. Not been strong, not been strong. Again, but I think is just a nuanced way of talking about conjunction. So I would say that was not T and D and Y. The trade agreement fails, and the dollar is strong, and the yen is strong. And this last one, I would say, is a definite implication. You've got a trade agreement. As a result, one of them is strong, but they're not both strong. Okay. Because of the trade agreement, either the dollar is strong or the yen is strong, but disjunction, of course, can include both, whereas this says only one of them. So we have to exclude the possibility that they're both true. Well, okay, these are my answers. You may disagree on one or two of these. And like most of the course, the focus is actually not on the answer, it's on the thinking process. The benefit from doing an exercise like this is not really whether you get the same answer as me. It's the thought process you went through in order to take something in English language and formulate it in mathematics. This is actually a very special case of what's known as mathematical modelling, taking a problem or a statement in the real world and representing it within mathematics. Mathematics is precise. The real world is usually not so precise. There's a loss when you go from the real world to mathematics, but there's also a gain. You gain precision at the cost of losing some imprecision. And when you do that, there are often choices to be made. Okay, well, how did you do on the whole assignments?